Good morning, grade 10s. I'm at home today. I have some cold symptoms and was told to stay home. So we've got good news and bad news for you. The bad news is we don't get to play Connect 4 today, but the good news is you still get to write your quiz. And that's what we're going to do first. So, Ms. Peters, you go ahead and you can pause the video while you put the quiz out. And once everybody is done, we will be marking it together. So when everyone's done, you can go ahead and hit start again on the video. Good luck, everybody. Make sure that you're showing all of your work. So you need to put your pencils away and you need to do your marking in ink. You'll be marking your own quiz. And remember, I always do an honesty check. So please make sure you're paying attention and that you know what the marks are being given for. All right, so number 1, working on our terminology. The way we're marking this one is if you have everything in this column correct, give yourself 1 mark. If you have everything in this column correct, give yourself 1 mark. And the same thing for this column. So for each column, you get 1 mark or 0 marks. No partial marks there. And Ms. Peters, feel free to hit pause anytime students have a question or that they want to discuss one of the questions if you can help them, or maybe they can even help each other a little bit. All right, number 2A is just 1 mark. If you don't have these terms in the right order, you're only getting half a mark. And for B, what we're getting is 1 mark for each term. And again, if you had all the terms right, but you don't have them in the right order, you would only give yourself a 2.5 out of 3. And for C, similar marking here, 1 mark for each term that you have correct. And if you have wrong order, you're going to dock yourself half a mark. And notice the setup for this one. First thing I did was I found the sum of this and this. So I added those two together, and here is the sum. Now I have to subtract this sum from this trinomial. So the order here is important. You have to have this one first and this one second. So that's a careful reading question. In number 3, expand and simplify. So technically this is a BEDMAS kind of question. Pardon me. We're looking at a BEDMAS kind of question. So you must multiply first and then collect like terms. We're giving 1 mark for each correct term. Now remember, when we say correct term, pardon me, the sign in front is part of that term. So when I look at this term, it's a negative 17. Positive 17 would be wrong. Same marking on this guy, 1 for each correct term. And then please do a subtotal of this page. What did you get out of 14? And we'll move to the back page. Okay, and through here, I'll just let you check your work over. Same kind of marking here, 1 for each correct term, and docking half a mark if it's a wrong order. If you've made a mistake, compare your work to mine and make sure you understand where your mistake is. And then with number 4, we're actually still doing that same kind of marking. So 1 for the 19x squared, 1 for the 22x. And half a mark off if you have it in a different order. And compare your work. This one's a little tougher to compare your work because you may have used a different strategy than I did. Perhaps you used the subtract strategy. Perhaps you separated your rectangles along here. So our work might look different, but our answers should be the same. And then with our numerical response here, it's 23 for your final answer, 1 mark or 0 marks. No part marks on this one. So let's take a look at number 5 because these are always a little tricky to understand. If the polynomial has a degree of a leading coefficient b, and a constant term c, then find the value of 2a subtract 2b plus 3c. So here it says the degree is a. So I get the degree from the highest individual term degree, which is 4. So a is equal to 4. Leading coefficient of b. Now, if this was in the correct order, we'd see as the lead coefficient. So b is equal to 3. And c is the constant term. And the constant term is the number that doesn't have a variable. So c is equal to 7. And then I'm substituting the a, b, and c in here. That's the work to explain it, and we get 23. So please give yourself a total on the back page out of 20, and then go back up to the top. Make sure you do your grand total here out of 34. Please be sure that you have your name, your first name, and your last initial. And go ahead and hand your corrected quiz into Ms. Peters. Once that's done, we're going to come back to the video and we'll get started on lesson 3. All right, we are getting into our factoring. And we'll be factoring for the rest of this unit. This is that big topic I've been talking about and how it will carry over to grade 11 and grade 12. Today's lesson is really like the building blocks of factoring. So I want you to be sure that you understand as we go along. And although I can't answer your questions through this video, you might be able to help each other out, and Ms. Peters might be able to help you out as well. So Ms. Peters, anytime you feel the need to stop the video, just go ahead and hit pause and discuss whatever is necessary. All right, so factoring polynomials. We should be in our notes booklet on lesson 3 and taking notes as we go along. So factors are 2 or more numbers or expressions that multiply to equal the original number or expression. For example, 8 is equal to 4 times 2. So 4 times 2 are the factors of 8. Now we can do that with an expression as well. 2x and y, these are the factors of 2xy. Monomials are pretty easy, very straightforward. To factor a polynomial means to write the polynomial as a product of factors. So we're rewriting the polynomial in a different form. The polynomial is completely factored when there are no common factors left in each term. Now, all of that will make a little more sense once we get to our examples. So we're going to see a little comparison here. We talked about it the other day, how expanding a polynomial is kind of like the opposite of factoring a polynomial. So over here on the left side, we won't have any variables in here, just looking at arithmetic, at numbers. So multiplying factors, 4 times 7, we multiply them, we get 8. Factoring a number, we get 28. Factoring a number, you'd start with the 28, and your job would be to say what are the factors that multiply to give 28. So you've done that before with numbers in the past, factoring numbers. And what's going to be new now is we're going to be factoring polynomials. So now we've got some variables in there. So if we were doing an expand question, it would look a lot like the questions you just did on your quiz. You'd start with this. So this would be given to you, and your job would be multiply it out to get your answer. Now factoring is going to be backwards. Factoring, it's like the answers given to you, and your job is to figure out what would the factors be that multiply to give you that binomial. So today's topic is just about removing a greatest common factor. This would be the first step of factoring every single time that it's possible. So this first step, if we make a mistake on our first step, it's hard to get anything else right. So it's very important. So we're going to just take a look at this process right here. We're going to be given a polynomial. Our job will be to find the greatest common factor. And then the other factor, there's really nothing special. It's just kind of what's left over after you divide out the greatest common factor. So here's how that works. What you can do here is you can think distributive property in reverse. So I'm going to find the common factor. I'm looking at 3x and 9, and looking at those two separate terms, I'm finding the largest number that I can divide both of them by, and that would be 3. And now to get the other factor, I'm thinking about distribution. What would I need here so that when I distribute, I'll get the 3x? So I'm going to need an x right there. And then I'm thinking, what would I have to have here in order to get that 9? And I would need a positive 3. So what we see here is our factored form, which is 3 times x plus 3. And if you multiply it out, you see, oh yeah, that's really the same thing that we had in the very beginning. Okay, so a few examples that we'll do together. And what you see right here is sort of your thought process as we go through. So first thing we'll do, we're looking at these two terms. And we ask ourselves, what is the greatest common factor in each term of the polynomial? In other words, what is the largest number and or variable that divides evenly into both the 2x and the 4? So our common factor, greatest common factor, is going to be 2. And the other factor, this is where I do my distribution. I'm thinking about what else am I going to need? What would I multiply by here to get 2x? And what would I multiply by here to get the 4? So I'm going to need to have an x here and a plus 2 here. And then a little note down at the bottom here says you can always verify your answers by multiplying your factors with the distributive property to see if you end up with the original polynomial. So a little just mental check here. 2 times x is 2x. 2 times positive 2 is positive 4. So I know it checks out. All I've done is take the polynomial and write it in a different form. Okay, for number 2, I'm looking for a common factor for these two. So the greatest common factor, we call it the GCF, is 5. And the other factor, I'm going to need an x plus 3. So when I do my little mental check, 5 times x is the 5x, and 5 times positive 3 gives me the 15. All right, we'll do one more together, and then you guys are going to try number 4 on your own. So for number 3, again, looking at both terms, and the common factor there is going to be c. The other factor will be d minus e. All right, please go ahead and give number 4 a try. So I don't think we'll need to hit pause. I'll just kind of hang on here while you guys are giving that one a try. Okay, so always start by looking for that greatest common factor. So this time I can divide an x out of both terms. And this other factor, it's kind of like the leftovers. Kind of like, if you came in here and you divided by x on each one, what would be left? So I'd have 4x here plus 3. And again, always do that little mental check. X times 4x is 4x squared, and x times plus 3 is positive 3x. Now, this next one gives us the first time when we have to do something just a little bit more strategic. If the first term of the polynomial is negative, remove a negative greatest common factor, and then adjust the signs of the other factor. So normally on this one, I would just say there's a common factor of 3. But since the first term is negative, I'm actually going to use negative 3 for my common factor. And the other factor, I'd need an x, and I would need a negative 3. So when it says adjust the signs on the other factor, you have to make sure that your signs will work out. So -3 times x, that one works. And -3 times -3 is how I would get that +9. So you have to be very careful on that sign right there. All right. I want you to try these 4 questions. We'll see how well we can do with these, and then we're probably ready for practice time. So, Ms. Peters, if you would hit pause and let the students give these ones a try. Guys, feel free to help each other out. Feel free to discuss, and then we'll hit play and we'll take them up. Go ahead. All right, so number 6, I'm looking for my greatest common factor, which would be 2x. My other factor, I'm going to need an x here. Now make sure you're thinking about distribution, because 2x times x gives me that 2x squared. And you have to think about what are you going to need here to make this 2x happen. So we have to be sure that we include the +1. And that can be a little tricky sometimes. There will be lots of times where people are going to forget that +1. And I think that comes from when we do this division idea. So once I've figured out that my common factor is 2x, lots of people, what they do to find the other factor is, I showed it to you just once before, they come in here and they go, oh, I'll divide by 2x to figure out what goes in the bracket. So they divide here and they say, oh yeah, x is left over. They divide here and they say, oh, there's nothing left over, and they forget to put the 1 in here. So watch out for that. All right, on this one, I look at the coefficients, and I don't see any common factors for the coefficients, but I do see that there are x's in every term. So x will be a common factor, and now I have to figure out what is the exponent on the x. And what I have to do is I look at all the x's that are in the question, and I have to take the lowest exponent that I see. So x squared. Do the same thing for the y. So y is common to all of them, so I can pull out a y, the lowest y that I see. And then my other factor, to make that first term, I'm going to need a 3x. To make the second term, I'll need a -2xy cubed. And to make that third term, +7y to the 4th. Now, you're fully factored when there are no common factors left. So one way we check is by distribution. So if I multiply here, that one checks out. If I multiply here, that one works. And multiply here, this one works. But the other thing we should look for is look in the bracket and make sure there are no common factors in here. Because if there's still a common factor lingering in there, then it is not completely factored. Okay, number 8, there's one of those ones where the first term is negative. So instead of pulling out a 5, I'm pulling out a -5. And the other factor would be x minus 2. And then 9, a little bit of a tricky one here. 9 doesn't have a common factor. So this binomial cannot be factored. Similar to if I gave you the number 11 and said, give me the factors, The only factors you could give me are 11 and 1. So 11, that's a number that we call a prime number. Well, this is a polynomial that we call prime. So when you face one of these, you can either say it cannot be factored, but you could also just say prime. All right, one last one. Let's do this one together, and then we're on to our assignment. So start by looking at the coefficients. We have 16, we have 32, and we have 8. So the biggest number that I can divide out of all of those will be 8. Now also notice that the A is common to all of them. So I can pull an A out of all of those, and I have to pull out the A with the lowest exponent. So A squared. And then notice there's a Y common to all of them. So pardon me, I'll be factoring out a Y from all of them as well, because that's the lowest Y that I see. And now think about distribution. What would I need here so that I can multiply to make this term? I would need just a 2. And then let's work on this guy. What would I have to multiply by to get a negative 32a cubed y cubed? I would need a negative 4a y squared. And then our last one, working on this guy right here, I would need to multiply by a positive. Now you don't have to put this 1, but you can if you want. A positive 1a. Now you guys who are on top of it, and I know that's most of you, you might be looking at this and saying, ooh, this is not in the right order. But you know what? In factoring, this is one of the times where you do not have to put them in the right order. We want to keep it in this order because then we can actually see that distribution and how it works out. So never worry about reordering the terms when you're factoring. Okay, so guys, we are going to go ahead to our practice assignment. So the lesson 3 worksheet is in your worksheet booklet. And when you're doing these questions, remember that dot, dot, dot means that you just keep going. So you're going to do every second question until you run out of questions. You'll do that for number 1, number 2, and so forth. These extra challenge questions are optional. So anybody looking for a little extra challenge, please give those ones a try. All right, everybody. I guess that's the lesson for today. We'll finish those other examples on Monday. Please work hard at this assignment. Be good for our guest teacher. And have a great weekend, guys. Stay strong and be kind.